So say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo.
Section 3.2, Solving Systems of Inequalities by Graphing. So a system of inequality is just a set of inequalities that we've already learned how to graph. To solve a system of inequalities, you're going to graph each inequality just like we've already learned in previous chapters. The difference is you're going to graph multiple inequalities on the same coordinate plane. Once you graph each inequality and shade the correct region, the region that's shaded for all inequalities is the one that you're going to highlight because that's your final solution to the system. The different lines that we graph, whether they be dashed or solid, are called boundaries, and the places where those lines cross are called vertices. You need to be able to identify the vertices of each of your systems of inequalities. The first problem has two inequalities in this system. The first inequality, y is less than 6, is a horizontal line at y is equal to 6. We know that that line is going to be solid because it's an equal to problem. So at y is 6, we are going to draw a horizontal line. Y is less than 6, therefore we are going to shade where the y's are going down. In the next problem, y is greater than -3 plus x. -3 is my y-intercept. So we're going to go down 3 and put a dot. My slope is 1, so we're going to go up 1, right 1. I know that this line is dotted because it does not have an equal to symbol. It says that y is greater than -3 plus x, so I'm going to shade up. When you're shading, you're only going to shade the part that already has shading on it. That way you can more easily identify what is your solution, and then highlight your solution. The highlighted portion shows your solution, and although we cannot see it on this graph, there is a vertex out here where the two lines cross. Problem B. The first inequality has a y-intercept at 4. So we're going to go up 4 and put a dot. The slope is at -3, so we go down 1, 2, 3, and right 1. We know that this is a solid line because it is equal to. It indicates that y is less than -3x plus 4, so I'm going to shade down. Remember, you can always pick a point to plug in. The next equation says that y is greater than or equal to 2x minus 1. The y-intercept is at -1. So we're going to go down 1 and put a dot. The slope is 2. So we go up 2, right 1, up 2, right 1. We know this is a solid line because it's equal to. We know to shade up because it says y is greater than. Remember to only shade where there's already shading. Your solution is where we have all the shading overlapping. So that's the part that we highlight. We have a vertex here on our graph at 1, 1. There aren't any other vertices and the would continue forever in the left-hand direction. Number 2. The most Kayla can spend on hot dogs and buns for her cookout is $35. A package of 10 hot dogs costs $3.50. A package of buns costs $2.50 and contains 8 buns. She needs to buy at least 40 hot dogs and 40 buns. Graph the region that shows how many packages of each item she can purchase. We need to first identify our variables. X can represent how many packages of hot dogs she has. Y can represent how many packs of hot dog buns she has. The first equation we can create has to do with the amount of money spent. If I take $3.50 and multiply it by the number of packs of hot dogs, I should get the total amount that she has spent on hot dogs. So 3.5x represents how much she spent on hot dogs, plus 2.5y represents how much she spent on hot dog buns. We know that the most money she can spend is $35. So I can represent this inequality with a less than or equal to symbol. The second equation we can create has to do with how many total hot dogs she has. She needs at least 40 hot dogs. Each hot dog pack contains 10 hot dogs. So 10 hot dogs times the number of packs she purchases, x, has to be at least 40. So we can represent that inequality with a greater than or equal to symbol. The last inequality we're going to create has to do with how many hot dog buns she has. 8 hot dog buns a package times how many packages she purchases has to be at least 40. I'm going to graph the first equation in green. In order to figure out a scale to graph, we can identify what our intercepts are. By covering up the x term and solving for y, we can identify our y-intercept happens at 0, 14. By covering up our y term, we can identify that our x-intercept happens at 10, 0. The next equation only has an x in it. This tells me that it is a vertical line. So I only have an x-intercept. If I solve for x, the x-intercept is at 4, 0. The last equation is just a y== equation. Therefore, it only has a y-intercept because it's a horizontal line. If we solve for y, we know that the y-intercept happens at y is 5, or 0, 5. The highest x value that I need is 10. So I need to make my x scale at least go to 10. I can count by ones. The highest y value I need is 14. This only goes to 10, so I'm going to need to count by twos. The second equation will be graphed in red, and the third equation will graph in blue. Equation number 1. We already have 2 points, so we can just go ahead and plot our 2 points and draw our line. I know that it'll be a solid line because it's an equal to 0, 14, and 10, 0. Since y isn't alone, I need to select a point to plug in for x and y to decide where to shade. I select 0, 0 to plug in. If I plug in 0 for x and 0 for y into this equation, I get that 0 is less than 35, which is a true statement. So I'm going to shade towards the 0, 0. The second equation I've already identified is a vertical line, and the x-intercept is at 4. Therefore, it's a vertical line at 4. It's equal to, so it's a solid line. We know that x is greater than, so I'm going to shade to the right. Our last equation is a horizontal line through the point 0, 5. We know that it's solid because it's equal to. Y is greater than, so I'm going to shade up. This triangle is my solution set. Part B asks to give an example of 3 different purchases that she can make. Problem number 3. The first inequality has a y-intercept of 1 and a slope of 2. So we go up 2, right 1. We know that it's a solid line because it's equal to. Y is greater than, so I'm going to shade up. The second line is that y is greater than 8. Therefore, it's a horizontal line at y is 8. We know the line is solid because it's equal to. Since it's less than, we're going to shade down. Remember, only shade where there's already shading. It may be helpful in the last problem to get y alone first. To do that, you're going to subtract 4x from both sides, leaving you with 3y is greater than or equal to negative 4x plus 8. Divide by 3 all the way across, and we get that y is greater than or equal to negative 4/3 x plus 8/3. Our y-intercept is 8/3, which is approximately 2.6. Our slope is negative 4/3. So we're going to go down 1, 2, 3, 4, and over 3. 1, 2, 3. This is also a solid line because it's equal to. Y is greater than, so I'm going to shade up. The triangle is my solution set. Now we need to identify the vertices. Since they don't seem to cross at nice places, we can use our calculator to help us find the vertices. Type each equation into your y equals. Then select 2 equations to graph. You can tell your calculator not to graph one of the equations by unhighlighting the equal to. I'm going to graph the first 2 equations. Remember to hit zoom 6 the first time you graph. I can find where my 2 lines intersect by going to Second, Calc, and selecting option 5. Remember to use the left and right arrow key to get close to where it intersects. Make sure after you press enter that it's still close to where it intersects, and press enter 2 more times. This intersection is at 3.5, 8. Then go back to y equals. Select another pairing to graph. This time I want to graph the first equation and the last equation, so I'm going to unhighlight the equal sign for the second equation. To find the intersection, press Second, Calc, and select option 5. Use the right or left arrow key to get close to where they cross, and press enter. Make sure they're still close and press enter 2 more times. My second intersection is at 0.5, 2. So my second vertex is at 0.5, 2. Then go back to y equals and select the final 2 equations. I'm going to unhighlight the equal sign for the first equation and re-highlight the second equation. Then graph. To find where they intersect, press Second, Calc, and select option 5. Use your left and right arrow key to move close to where they intersect, and press enter. If it's still close to where they intersect, press enter 2 more times. My final intersection is at negative 4, 8. So my final vertex is at negative 4, 8.